Hey everyone, welcome to the Wednesday night stream. Welcome back to Mastermind Academy. Tonight is part two in our Linux journey. We're going to be diving into more operating systems management with Linux. Let's check out the chat as usual. Let's do a little bit of a roll call here. Like to see who's in here. Like to see where you're from as well. Hey T-Rex Test, we got your message. Welcome to the stream. We can't wait to move into a sysadmin or DevOps role. Absolutely. I think I started out as like desktop support with sysadmin, then into DevOps. Moves pretty quick. I'm glad you're on here. It's a good step in moving into one of those roles. What's up, Suge White? You've absolutely cemented yourself as a regular. You're definitely a name that I recognize. So welcome back for sure. Free stream slapper plan, appreciate it. I'm gonna switch up the songs. I'm gonna try to switch up the songs like every 2 weeks to keep it fresh. I'll probably change up the intro a little bit once my editing skills, my After Effects skills get a little bit better. I'll probably have some better starting soon intros made out for that. Cool, looks like I got the GitHub going. We already got some good chat commands going. Cool, right on time. I'm always gonna try to be right on time. I was actually almost a few minutes late. I think I told you guys a few streams ago that my dog was getting surgery. Now she's downstairs resting, but she can't walk up the stairs on her own. So she would try to walk up here. So I had to kind of barricade her off, make sure she couldn't get up here. But she's back with us. She's down protecting us, you know, while we stream, while we're working on all of our cool tech stuff. You know, she'll be watching over us, making sure nobody can come upstairs. Cool. Gettysburg again, Richmond. Hey, everybody. George here from Spark. What's up, George? I work at a place, the company I work for works at a pretty cool co-working space out of Spark, Baltimore, which is a pretty cool spot. So there's a lot of companies that work in there, a lot of different people in there. How you doing, George? You know, that's Hyper-V. Absolutely. I knew someone was going to bring up Hyper-V last time. I wanted to leave that out for a little while, just because I don't think you'll come across, at least in my experience, you won't come across Hyper-V that much in the professional field. Definitely, Hyper-V is definitely an up and coming, I would say becoming a more prevalent virtualization technology, especially in the like personal computer game. But yeah, so we can definitely share some resources on Hyper-V. Put a message in the Slack channel about it. Maybe we can start some conversations around Hyper-V. But cool, tonight is again part two of what we started last time. This is our journey into DevOps. Journey into Linux, and this is part two. So last time around, maybe we can recap some of the things that we learned. We learned about the different types of virtualization. We learned about type 1 and type 2 virtualization. So we've got bare metal virtualization, and we've got host virtualization. And so we learned a little bit about that. We learned a little bit about the different applications that we can use to virtualize applications and operating systems. Then we learned some basic Linux things. So how to install Linux, you know, in a virtual machine. You can actually do that in the same way if you want to install it on your local computer. We learned how to set up users. We learned how to set up groups and how to manage groups. We learned a little bit about Linux permissions. We learned a little bit about Linux navigation, so how to, you know, find out where you are with the pwd command on the command line. We learned how to move forwards and backwards and move into the right directory that we wanted to move into. We learned about relative file pathing versus absolute file pathing. So that was great. So we learned we laid a foundation for what we're gonna kind of do tonight. And there's actually only 2 Linux streams because we're going to be using Linux throughout the entirety of this course. So everything you need to know isn't going to be told in these first 2 courses. And I'm actually, the next boot camp that I'm going to do is going to be shorter. It's going to be looking like right now it's going to be a 6-week boot camp, but it will actually be Linux, and I'm going to run it in tandem with another boot camp. So maybe something Monday, Wednesday, maybe something Tuesday, Thursday. I'll figure out the days for sure. But the next one is going to be Linux, to be able to deep dive into Linux a little more, and to really get super hands-on, really make you an expert at Linux. We're actually going to start targeting a lot of these. We're running through everything right now throughout the DevOps bootcamp, but we're going to start targeting in individual little workshops and boot camps each section really. So we're going to have one for cloud computing, we're going to have one specifically for Linux, one specifically for programming, so keep an eye out for those. Tonight we should be able to go a little bit slower than we've been going. There's a lot of stuff here. We have some things that we called out on the website and the curriculum that we're definitely going to go over, but there's going to be a lot of other commands and things and other tools to add to your belt throughout this stream. So again, sit back, relax, get comfortable. Don't sweat it if you don't understand everything that I'm doing. You know, ask questions, but also do a little bit of Googling. You know, if I do something that you don't quite understand, write it down. You know, do some Googling afterwards or during if you want to take a break. You can always pause the video. You can always rewatch it later, but you can look around for yourself, see what information you can find. Maybe something else is going to teach it to you in a way that a better way for you to understand than I taught it. But you know, it's all about exploring. Don't be afraid to type in these commands if you're also running Linux locally, or you have a Linux VM or whatever. Try it along with me. Don't be afraid to do anything. This is how you learn. Cool. So before we get started, let me take another look at the chat. Let's see. Underlying issue with Linux over regular Windows. Total noob here though. I did install virtual machine, but Linux just doesn't run well. Kind of like remoting to another PC. That's exactly what it's like. So this virtualization is relatively heavy. Host virtualization type 2 virtualization is relatively heavy. So if you don't have a super beefy computer, or you don't have a lot of resources to spare, it can be slow. And that's why I kind of recommended maybe picking up a Linode server or a Amazon Lightsail server or DigitalOcean droplet to be able to do some of this stuff in. On Windows, I should have gone over it. I wanted to go over the Windows subsystem for Linux. I think that we'll have some time to do that tonight, but there are some other ways in Windows that you can kind of run Linux or be able to run a lot of these basic Linux commands. So hopefully I can help you out with that a little bit later, Sebastian. How do you transfer files from your host PC to VirtualBox? So there is a setting inside of VirtualBox that allows you to both drag and drop and copy files from the host system to the virtual machine. There's also ways to mount your host machine's drives and files and folders into VirtualBox. Do a little Googling on that, and maybe we can maybe I can put you to some videos or something to help you do that, but it's a pretty simple thing. I think there's like a checkbox in the options to be able to drag and drop things between two of them. But cool, let's get started. So Tux for President, the second term, we're in part 2 now. So let me click in. Cool. We're gonna hop right into it with packages. So what are packages? Packages are very important in Linux, but what are they? So packages are they're application formats that allow them to be easily managed. So that means downloaded, installed, uninstalled. And to do this, we have to use things called package managers. So there are other ways to install packages, and we're going to talk about that after this, but packages are a very common way. They're a very convenient way for you to manage the applications and tools that you have available to you on your Linux machine. Some of the common ones, so for Debian-based distributions, so these are going to be your things like Ubuntu. I think we confirmed that the Raspberry Pi running, Raspbian, is also a Debian-based distribution. We'll be able to use a package manager called apt or advanced package tool, and I'm gonna show you shortly how that works. But again, this is just a package format. So this is a tool that was created that kind of creates this format that packages have to be, or applications have to be, kind of balled up into. And once they are put into this format, people can use this package manager to easily get them installed in the system. So it knows where to move pieces of the file, pieces of the application. It knows what to do with all that stuff so that you don't have to do it manually, which is really, really nice. Another one on Debian, so if you're also using Debian, it also runs an underlying one called DPKG, which I think is just Debian Package Manager or Debian Package. I think, could be wrong about that, but Debian does have both those available to you. So if you're running Ubuntu, and that's what we downloaded last class, so you will have both of those available to you. You'll use apt for most things, Debian for a lot of other things. The system uses DPKG for a lot of things, and I'll show you guys how to use both of those. And the other big one that I want to call out is Yum, and that's for any Red Hat based distribution. So Red Hat and CentOS. This is a lot of enterprise companies will run these distributions, and so you'll use Yum pretty often. I also think Amazon Linux uses Yum as well. I'm not 100% sure. I can't really remember, but I'm pretty sure they do. That stands for the Yellow Dog Updater Modified package manager, I guess. I had to look that up today. I had no idea what Yum meant, but I've been using Yum for years. But that's what it's called. People will always refer to it as Yum, and they are Yum and apt are pretty similar. And there are a lot of other package managers, which I'm going to show you in a second. But we're going to go over these first. So let's show you why these package managers are important. So here I'm running a Debian-based distribution. So let's say you have hopped into a server. So when you get dropped into a server, there will be no graphical user interface. So how are you going to install a package when you don't have access to a browser to download these things? How do you get packages and tools installed? You can do it through this package manager. So I'll just type in apt and let's see what happens when we type in apt. When I type in apt, I get a bunch of output, and lets me know what it is. It's a command line package manager that provides commands for searching and managing, as well as querying information about packages. Cool, very simple. It just means it's a tool that I can use to do lots of different stuff when dealing with packages. So let's say I know, so one, it helps if you already know the package names, but you can use apt to search. So you can see here, we can do apt search. And let's say, hey, even though this is not an application that you would want to install on a server, most likely, I know, let's say I set up my Linux system, and I do have a GUI, and let's say I do some photo editing, and I want to install the open source tool GIMP, which is the GNU image manipulation program or something like that. But basically it's a tool, it's a Photoshop alternative in Linux that allows you to manage photos and to change photos. So let's say I didn't know what that package was called. So I could do apt search GIMP, and it would do some searching and it would let me know all the things that I kind of have available to me. Unfortunately, it shoots out some other things that are it shoots out a lot of the dependencies in GIMP, which is kind of annoying. So I get a lot of package names here. You almost never need to do this. Your best option would be to search, like, basically how to install GIMP via apt or something like that. Or there's some repositories and places online that I can show you where you can get the correct package name for the package you need. But to install a package with a package manager, all you have to do is sudo. Don't forget sudo. And again, for you, those of you who don't remember what sudo is, that is super user do. That allows me to escalate my privileges to a super user, to the administrator, to root, basically. And so I'm going to do apt install and GIMP. I know the package name is GIMP, and so I'm going to do this. So I'm going to put in my password. Cool, and just like that, it runs through, it starts checking things. It starts checking all the packages that I need, all the things that making sure I have all the dependencies and things that I need. There's a lot of output here. It's not too important that you go through and read all of this. You might want to, if you're running an important production system, it'll let you know what extra packages that it needs to install if it does need to install packages. So you might want to check that, and if it does need to install a bunch of packages, it will ask you yes or no, because there are times when you don't or can't install certain packages on a machine. But it'll go through and it'll install it for you. So just like that, I have installed a new application, and I can prove that to you by going into my applications and typing in GIMP. And just like that, I have this tool here, and let's open it up. GNU image manipulation program. Yep. So now I've got a program here just like that. I was able to very easily install this program, and now I have it on my computer permanently. I can update it and things like that. But you can see how easy that was, and you can see how package managers are great. This is just like your Mac OS App Store or your Windows Store, which doesn't really have as many programs. It's kind of the same idea. It's a little bit easier to use. It's a lot faster. And because it's in the command line, later, especially next class on Monday, I'll be showing you guys how you can use scripts to automate this process. Because it's done via the command line, you can easily automate the installation of packages and things like that. So it's pretty cool. So just like that, I have programs installed. I can install other programs like VLC. If you guys don't know what VLC is, it's a media player, and it plays like all kinds of stuff. And now, if you see here, it's important to look at errors sometimes. Well, it's a lot of text and it might be confusing at first, but take a look at what we have here. It says could not open lock file, and you can see varlib dpkg. This is just a file path. Remember, we talked about dpkg being a package manager, and then it says permission denied. And then if you read the second line, there's a bunch of extra stuff, and then it says, "Are you root?" We talked about this before. Sudo allows me to run, that sudo command allows me to run things, with escalated permissions. Whenever you see something like this, permission denied or "Are you root?" If you know you're doing the right thing, if you know what you're doing is a safe thing to do, go ahead and throw sudo in front of it and try that out. That's almost always the reason why. So cool. So we're gonna do this. We're gonna install VLC again, which is a media player. It's a very common media player. You can use it on Windows and Mac as well. Again, it's great because it's open source, and the file formats in which it can read and play is pretty vast. But just like that, I now have an application. Now I've got this media player here, so that's pretty cool. You can see how easy that was. Package managers are also great because you can do things like remove them. So if I'm tired of it, or this is not what I really want, I've tested it out, I can do sudo apt remove, and I'll do VLC first since I just installed it. And it's going to ask me again. It's going to say, hey, these are all the things that are no longer required. These are all the things that I'm going to delete. You can look through that if you're worried about it. Look through the list. Make sure you're not removing anything that you really need. And if you want to remove it, you go ahead and click yes, and you no longer have VLC. When I type in VLC, you can see I have no more applications called VLC. So super duper easy to be able to remove packages. Same thing again with GIMP. And this paradigm is the same amongst pretty much all package managers. If you're going to be using yum, it's sudo yum install, the name of the package. Very simple. I think to remove, I think it is still remove. I think it's sudo yum remove, or maybe it's delete or something. But the keywords might be different. But it's a very simple paradigm. It's the name of the package manager, the action you want it to do, either install, remove, search, list, and then the name of the package. Package names do change across distributions. That's very important to remember. GIMP may not be called GIMP on a Yum system or on a Red Hat based system. It does differ amongst distributions, so you do have to look those things up. I think you can look up what these packages are called. Let's Google it real quick, because I don't know offhand what they are, but let's go ahead and Google, see if we can find the site where we can find the file. So let's see, apt. Let's just Google apt packages. Maybe we'll get something. Perfect. Very, very simple. This takes you to packages.ubuntu.com, and here is where you can search for the packages that you want. So maybe, again, I want to find GIMP, and I can see here that there's a package GIMP, there's a package GIMP CBM plugs, and there's all kinds of different packages here. This does a very similar thing to the search that you can do from the command line, but this is a little bit easier to see, a little bit easier to parse through, if you don't have great bash foo. So yeah, this is just a place that you can go to get those package names if you need it. Yeah, and again, it's really important to note that those package names may differ amongst distributions. So stop there for a second, and actually, one other thing I want to show you is that you can install apt install multiple packages in the same command. So GIMP, I don't know if I already have Inkscape on here. Let's go with that. Well, I'll just do VLC and GIMP. You can just, with a space in between, making the space the delimiter, you can install as many packages as you want. So I could just keep running down this line. I can do like MySQL, and cool. I'll just do this and not MySQL, because I don't, it's saying it's unable to locate my package MySQL because that's the wrong package name. There's another package name somewhere that I can find on that site that would be needed to call MySQL. But I can install both these packages in one command. And again, it could be any number of packages that you wanted, and it would install them in a single command. And now I have both GIMP and I have both VLC available to me now. So that's pretty cool. And that's why package managers are great and exciting. Cool. So package managers continued. So we talked about two big package managers. Those are probably the two most common package managers on what I would consider enterprise systems or work systems that kind of run on servers. There are many other package managers, depending on which distro you download, that may be available to you. One that's two actually that are common on Arch Linux, I think OpenSUSE as well, are Pacman. So Pacman, it's very similar. I think it's Pacman-S to install in the name of the package. So that has its own repository of packages that it maintains. Yowert, I'm pretty sure that's the right spelling of it, but that is the Arch user repository. So that is, again, for Arch Linux. Arch Linux is a pretty cool desktop distro for the most part. Again, any distro can be used for servers as well, but most people use Arch for desktop. Arch Linux is great because you don't really get anything out of the box. Like, you manually have to tell it, you kind of have to build it up yourself. So you only get the tools and things that you really care about and that matter to you. So it is a little bit of a learning curve kind of hopping into Arch, but it is really nice. It usually makes it pretty fast. But Yowert is the repository for packages in the Arch user repository. DNF is, I think, a relatively new one. Maybe it's been around for a while, but I've only seen it crop up recently on distros, specifically a distribution, a very popular distribution called Fedora. So Fedora is based off of Red Hat and CentOS, but is designed to be a little more cutting edge than those two. So you might see DNF if you decided to use Fedora, and it's very similar to Yum, but I don't really know much about it, but it seems to be similar to Yum. Thanks, Big White. Yeah, DNF is a Yum replacement. So that's what I've noticed it to be, but it hasn't quite rolled out to some of the more popular distributions yet. And then the last one I put on here is Snap. Snap is a little bit different than these, but it still is a package manager. It is used to be able to install applications very easily on a system. You can I think I did it last class, someone mentioned it, so I threw out a Snap install on a program, but I think Snap does it in a way where it's actually little containers running. I've noticed that Snap, and I'll be able to show you this later, but Snap does some weird stuff with your file system, and kind of just how the applications have to run, and that's the reason I don't use it more, but it is pretty cool. It's pretty cool to use. It runs, across distros, across operating systems. Not operating systems, but across distros. I'm pretty sure it's Linux specific, but these are some of the more common package managers. There are a lot more package managers out there. It's not important that you know them, the ins and outs of them. There are some caveats, and there's some great things to know about Yum, and we will dive deeper into Yum a few courses from now, because we'll have to modify some of our Yum repos and stuff to be able to get certain packages. But there's some cool things to learn inside of Yum and inside of apt, but these are just some of the main ones. Another cool thing you can do with package managers, though, is do widespread management of your application. So it has a handy thing that you can do. You can update your packages. You can upgrade your packages. These two commands actually do the same things. Almost. They do the main intended action of them is the same. So they will go through and they'll get the latest and greatest for all of the packages that you have on your computer, and you can do that in one fell swoop. The difference between update and upgrade is usually on enterprise systems. Usually on your work systems, you're going to be doing an update. An update will update those packages, but it will not, it may or may not delete old and unused unnecessary packages. Whereas upgrade will go through and delete packages as well, some that you may be using, which can cause problems sometimes. On my personal computer, I run upgrades all the time, but you may not want to do that on enterprise systems. Update is probably the one you're going to go with, and I can show you what an update looks like right now. And again, you still need sudo, and I'm going to go yum update. Oh, whoops, sorry. I try to use yum because I use yum a lot, and this system does not have yum installed on it. So we got to switch it up to apt. And it runs through and it hits all the mirrors, it hits all the stuff that it has set up inside of it. And it lets me know that there are 21 packages that can be upgraded. And this is what an upgrade looks like instead. Well, so apt update and apt upgrade are not the same. I think yum update and yum upgrade are. where the only difference is that one will delete. I think on apt, I think apt just, the update just pulls in like the latest stuff from each of the mirrors, I think. But I'm pretty sure on Yum they are the same. One just removes. But yeah, I don't know. I mean, maybe apt and Yum are different in that aspect. So definitely thanks for throwing that out there. Apt updates, make sure repos. Okay, upgrade, update your packages. Okay, perfect. I'm pretty. Yum may do the same thing, but I could have sworn one of them did. Like one of them deleted and one didn't, but that's something we can dive into. But yeah, that's good information. But just like that, I was able to upgrade a lot of the packages on my computer. There are tons of packages on here that you probably don't even know you need or use. You may not use any of these things, but it is good to keep stuff up to date pretty often. It's a very easy command to run, but a lot of times these packages will release security updates and little patches that make the application better. There are times when these updates will break your computer or break certain things, so you do have to be a little wary about it, but it is a good idea to implement some kind of method of upgrading these packages. I know like the project that I'm on, we update weekly. We build new Amazon machine images. We'll talk about that during the Amazon portion, but we'll build new systems where we run a full update weekly, and that's where we kind of make sure we have all the up-to-date packages. So cool, that is package managers. Pretty simple, not very difficult. So if you've seen me before, I think the very first Golang one, I really fast like hopped in here and I installed maybe Ruby or something, or Golang or something like that. And I know someone messaged me, was like, whatever you were doing in the beginning seemed kind of like magic. I was like, wait till we get to the package management portion. You'll see that the things that I'm doing are actually pretty simple. And again, it's a pretty simple thing, and they're pretty great. But what do you do if there's no package? So you saw me type in like yum install or apt install, sudo apt install. I think I tried MySQL. And it runs through and it says unable to locate package. What if there's a package that you think is supposed to be there, or that you can't find and that you need to install something, but there's no package in your repos for it? You can build it from source. So these package managers essentially they essentially do this for you. They're set up in a way that they can install these things based on the source file. So the packages that are created for apt, the packages that are created for Yum are all built. Someone builds these things from the source code, and they're done in different ways, but then they're put into a repository and made available for you to pull down. But what we can do is we can build those things from the source files. So applications and tools that are built to run on Linux can be installed by manually compiling its source code. And so we will go through and we'll do that. So I'll show you here, and hopefully I can pick an application that works well with this. Usually, in this day and age, you don't need to do this that often, to be 100% honest. Like, you'll definitely need to know how to do it. You'll definitely come across applications where you do, but you probably won't need to do this too often. But let's say something like Ruby. Now, I can definitely install Ruby via apt, and it lets me know right here, go ahead and install this package via apt, but I'm going to do this manually. So what I'm going to do first is I'm going to go get the source file. So I'm going to go to Ruby. I'm just going to Google Ruby downloads. I don't have a link for you, but I can paste it in. I'm going to go to the Ruby site. I'm honestly, right now, I'm actually just assuming Ruby will make these files available to me. And it says, see the installation page, details on using package management system. So I can probably go here. Oh, actually, compiling Ruby source code. Perfect. Exactly what we're looking for. So it sounds like, I'll open this up in another browser. It sounds like here it shows you, you can use the different package managers to install things, to install Ruby. So, it makes it really easy. This is why package managers are great. But what I can also do is head in and grab the source code. So I'm going to copy this link. So I'm going to right click and copy, I don't want to save link as copy link location. So if I click on this, it'll download. But I don't want to download this from the browser. You can absolutely download it from the browser. I just want to show you how to download it from the command line. So I'm going to move into my documents. So remember, we talked about the CD command, the change directory command, and I'm going to move into my documents. And so in here, I've got this stuff here. I'm gonna make a directory called Ruby. You don't need to do this as well. I'm just doing this so that things are, you know, organized and I can find them later. So I made this directory called Ruby, and I want to move into that directory. How do we change into that directory? We cd Ruby. Cool. Now, again, you won't have from most servers, you will not have a graphical user interface. You won't have a GUI. So you won't have this browser that you can go to get that link. So you may get it from somewhere else. But when you have that link, if you want to download something from the command line, there's a few different ways you can do it. So you say, what happened when I clicked the link? Oh, what happened when I clicked the link? All that happened was it started to download and I just hit cancel because I don't want to download it right here. So normally when you click on the link and download something, it downloads to your downloads file. I could absolutely do that, and I'll show you. I can save that file. Cool, it downloads, whatever. But what we want to do is we want to learn how to download things from the command line. So we can use a tool. Oh, okay, sorry, I missed that. So we want to use a tool called wget. Wget is a command line tool. You might have to install it. I might have to install it right now, and I can do that through apt. But it allows you to download packages from the internet. Not even just packages, it allows you to download any downloadable file from the internet. So I'll do that, and you'll get some output here, let you know that it's awaiting response. We will talk about internet response codes, but whenever you see 200, okay, that is a great thing. Always be looking for a 200. And you can see my status bar, 100%, and it's downloaded. It said it saved it as a file named this. And if I do an ls here, cool, now I have a file in this brand new directory that I created. So building a file from source. Everything that's in this tar.gz, so it's not really important that you know what a tarball is right now. This is a compressed tar file, a compressed archive. Think about it like a zip file. All this is just think about it like a zip file for now. We'll learn more about that later too. But it gave me all the files in this compressed zip file basically. So first thing I'm gonna do is I am going to unzip it basically. And so on Linux, well, on any computer, so Mac or anything, the way you unzip a tar file, so if it was a zip file, I'd really just type unzip. But tar is a little bit different, and I have to do tar, and I have to pass it some options. So I'm gonna do a -x, and I think this is for extract, so this will extract everything. I'm gonna add in a V for verbosity, so this is gonna mean verbose. This is gonna let me know what it's doing. If I don't put the V there, it'll run through and it'll uncompress it, and it won't let me know what it's doing. I like to see what things are doing, and so yeah, it'll do that. I think the Z is to decompress the gzip portion of it, and F I think is give it the same file name. I think I can look at what those flags are later, but it's not important that you remember this tar command at all. I had to look up how to extract a tar file every single time for over 2 years, like I just did, because you don't need to know the syntax for doing these things. You need to understand that this file, that whenever you see this tar.gz, it's a type of compressed, bundled up file that you need to extract, that you can make bigger, just like unzipping a file. So we're gonna do that, and we're just gonna type the file name. So when we do that, because I added in that -v, it lets me know that it's spitting out all these files. Cool. And when I see what's in this file right here, I can see that there's a folder here now. This folder wasn't here before. There was not a folder here before, but when you uncompress this zip file, basically, you get this folder, this uncompressed folder. So now there's something that we can go into. So we'll go into this Ruby folder. Cool. So building files from source. Actually, there's hopefully this works by default. So there are a core set of packages that you need to be able to install files by source. And let me see, apt development tools. Maybe this will give it to me. Let's make sure we have them before I do it. Cool. Yeah, there we go. So Yum has this as well. But you can go ahead and install these build essentials. And these are just the tools that you need to be able to build something from source. For your computer to be able to compile an application from source, you need these tools. They're probably, they might already be here. I want to make sure they're here. So I'm going to paste that in and go ahead and let that install all these tools. And okay, just like that, it kicks me back out. It's letting me know that I already have all these tools and there's no need to install anything new. Perfect. No big deal. So now we've got all the tools that we need to be able to build this. We have our uncompressed files. So this is everything that Ruby gave us. It gave us tons of files here. And we are now going to build it. The first thing that you need to do is you need to run, and so there's a lot of variation with this, but hopefully this is gonna be a very simple process. The first thing we're gonna do is run a /configure. What this is gonna do is it's gonna run through all of the files. It's gonna run through and check to make sure that I have all the dependencies that I need, make sure everything's good to be able to build this via make. So I'm gonna run this. It's going to take a little bit of time. It's going to run through all this stuff, and you can see it's checking whether certain things are this or that. So we'll let it run through, and we'll let that finish up. Oh, cool. What do we got here? All right. Looks like your Nightbot was a little too aggressive. There's something you need me to send. Maybe shoot it over at the Slack channel. Maybe I can paste it in if need be. Only know XDVF, pt2s. I never remember how to decompress. Exactly. It's not important that you remember, again, that syntax. You do it enough times, you'll remember which flags to throw in there. But again, just remember, just like a zip file, this is not special. I wish I had showed it to you. Actually, not wish I had showed it to you. I can actually just show it to you from the... Let me show it to you actually in a file browser, what a tar.gz looks like. And in a Ruby. And again, see right here, it looks just like a zip file. No different than a zip file. So just as of right now, just think about it like a zip file. And all we did was unzip it and we got this folder right here. So that's everything we're doing from the command. So let's go back in here. Cool. So we ran through and we ran /configure and it ran through and it ran all of this stuff. And it set up all the things that make needs to be able to run. So now all we're going to do is run two more commands. We're going to run a make command next. So /configure first. And so why do we need the /configure? I think we talked about this last stream. What happens if we would have just run configure? Because configure isn't something that is in our path, it would have been looking for a file or a directory. Like if I just type in configure, it'll tell me there's a command not found because there's no command on this computer called configure. If we just added a slash, it would say there's no such file directory because now it thinks that is a file path. It thinks that is a file path starting at the root of the computer. Again, we talked about absolute file pathing, and whenever you see that slash, think absolute, and it's looking from the very beginning of our computer and saying, hey, no such directory. Also, it's giving me this because I didn't actually tell it to do anything. So that /, remember dot means right here in this current directory, and that / allows me to kind of execute this configure thing. So actually, if I look at all the files, if I do an ls-l and I grep configure, you can see here that there was an executable file here, and you can see we talked about Linux permissions. It has read, write, and execute for the A-Brooks user. I'm A-Brooks. It allows me to do all three of those things. So I was able to execute this configure script. And so next thing we do is run make. Make will go through and it will, there's a make file in here. Right now, don't worry about what a make file is. Maybe do some research on a make file, but don't sweat that. This is the process for installing via source. It's almost always going to be this way. There's going to be some instructions, and I don't want you to get confused when you see the instructions. The instructions will almost always be similar to this. Maybe some extra flags passed in here or there, but it's going to be configure, make, and then we're going to do a make install, and that's the entire process. So again, start to finish, the process is download the source code. And you can use wget to do that from the command line. There's also a way to do it via a tool called curl, which I can show you. But you can get that file, download it, it's almost always going to be in a compressed or zipped format, or archive format. You need to extract that or expand that, go into that folder where the source code is, and start with your configure. So you run that /configure, you execute that configure process, then you're going to run a make, then you're going to run a make install, and your application will be there, or it should be there. It'll error out. If there's any problems, it'll let you know. But again, most of the time you have to install something via source. There will almost always be documentation letting you know how to do it. And actually, let's see if Ruby has that, where it tells me to download it. Ruby doesn't tell me what to do, but that's why I'm hoping this is a pretty standard, simple install. This should work. It should definitely work. So shouldn't take too long. We'll let that go for a little while longer. Does anyone have any questions so far about what we're doing? Again, it's okay if you don't quite understand. Some of the big takeaways is we are not using a package. We're using the source code. We talked about source code in the programming section, but we're using the source code of an application to be able to compile that application to be able to run on our computer. That's all this process is. It seems a little complicated because it's a lot more than apt install, but it's really just 4 commands to be able to do it. Yes. Yeah, while this is building, I'll open up a new tab here. Let's talk about man pages. We didn't talk about man pages, but while that's building in the background, man pages, I think it stands for manual, but it is a way to find out how to use a Linux tool or a command line tool from the command line. So you can do man, and let's do ls. I think we did ls last time, but basically this is a manual now on how you can use the ls command. So we know ls is how we see what's in a directory, and it lets us know all these options. So if I add a -a, it'll show me everything. It'll show me all, and basically that does not ignore entries starting with a dot. A dot in Linux, in terms of a file or directory, it means it's hidden. So in Windows and Mac, you have hidden files. You also have hidden files in Linux, and adding a -a will allow you to see those files. And we've got a lot of we have so many different options here. It takes a while to kind of figure some of this stuff out, but you can use these pages to learn how to use something. So I can do man make, and again, that make command is to GNU make utility to maintain groups of programs. And so there's a lot of information here. It can be a little complicated to read at first. There's some better tools to use to be able to do this, but get familiar with man pages because this is for sure what you will have available to you on machines if you need them. Same thing with like tar. So like man tar, and this is how I found out how to use the X and the Z and the V and all that other stuff. All that information is in here. Again, it's overwhelming. There's a cool tool though, which may help you in the process, called TLDR. And this is a Linux package, but it's simplified man pages. So basically it's so actually that's really cool. I just used tar as an example, but this gives you like real world usage and what you do. So create an archive from files and let you know exactly how to do it, and create a gzipped archive and extract. So I could have gone in here and found my answer, but TLDR is pretty great, and I'll paste this in for you guys to check out. It's a good tool to try to install. Do your best to try to install it. I think on Mac you can just brew install this. I think there's packages for different things for you to install this, but this is a simpler man page. It's a lot easier to read man page, but I'd also recommend getting comfortable with reading man pages. It took me, I'll be completely transparent, it took me years to start using man pages as opposed to Google. Now I'm very comfortable with reading them, and so if I need to figure out how to do this little thing or that little thing, I'll hop into a man page and find out. I'll find out what flag that I need. But before, I would just Google around until I found it. Still, again, a very suitable option, but man pages are a lot faster to do. show you all the man pages. I can't show you all the man pages, but you can take a look at all the man pages if you like, for sure. Let's see. Start reading. I can't. I can't. It's the most boring thing. It's so boring. It's so it's really boring to read. But again, you'll see a command. If you ever, what you should start doing is, as you see commands in tutorials or something, start manning those commands and reading through and see, just start to understand what it does, see what kind of flags it has. Sometimes the flags and things won't make sense to you. Try running those commands with those flags and see what it does, and see if you can start to put together kind of the verbiage that the man page uses to express what it wants to do. Again, it definitely takes a little bit of time to get comfortable with that. Cool. So let's check out now. Well, actually, let's see if our make command. So that's done. It took 42 seconds to install that, or to run that make command. The last thing we need to do is a sudo make install, and that will run. This shouldn't take too long, I don't think. Cool, just like that. So our goal here was to install Ruby. I typed in Ruby before, and we did not have Ruby. Now it doesn't give us a command not found. Ruby by itself, you shouldn't do that, but Ruby has IRB, and so now I have Ruby on my computer, so I can put hello world, and this is just a Ruby interpreter. Ruby's a programming language, if people didn't know, and so now I'm using Ruby. I can get out of here. I can do Ruby -v, and I can get the version of Ruby. So just like that, we were able to take the source code of Ruby, we were able to download it, extract it, configure it, install it, and now we have Ruby installed on our computer. So there are times where you'll need a package or a tool that's not available to you from a package manager, and this is how you can install it. Again, you don't need to memorize that whole process. Just kind of understand that when you see build it from source or install from source, this is the process that it'll take. It is pulling in those files and running a few commands that gets it to be able to compile it to be able to run on your system. And as you can see here, not too difficult. If this is your first time seeing it, definitely might seem like a lot was happening, but I wasn't doing a lot. I ran 4 commands and I was able to get that installed on this computer. Cool. Let's go on to the next thing. Actually, I don't need this. Build from source. So cool. Next thing is process management. What's running? So knowing what's going on with a system is a very important piece of operating system management. You'll have to do this on the job for sure. You'll have to know, what things are running, how things are running. We all know computers have limited resources. So someone asked before, hey, the VM on my computer is kind of running weird. It's kind of like me logging into another computer, not really running great. That's because all computers have a limited number of resources. So what that means is, you can only allot. So one, if people aren't familiar with how computers kind of work, and this is going to be important going into the next, 3 sections here, is the main pieces of your computer that are important. The resources that you care about are your CPU, so that's your processor. That's kind of the brain of the computer, the thing that's doing all the processing, all the calculations. It's a pretty important piece of the computer. Most computers have a single processor, and they're pretty powerful usually, and you can split them up accordingly. Some of them have a certain number of cores that you can use to split them up. Virtual machines have this concept of vCPUs, or virtual cores, that you can use to kind of split up and ration out those resources. Then you've got RAM, which is your memory. Whenever you hear people talk about computers, they talk about memory. It's talking about RAM, and this is your volatile fast access memory. So volatile meaning when you cut the computer off, the stuff that gets saved in the RAM it's ephemeral, it goes away. So if you shut the computer off and it leaves, nothing's stored here permanently, but it's used to kind of keep information readily available in the background. The more RAM you have, the faster your computer usually is, because it's able to keep a lot of that information, quickly available to you, and the processor is able to stick a lot of things in there to use in the long run. Computers typically have between 4 gigs and 64 gigs of RAM. Servers, have tons more sometimes, but yeah, so that's RAM. Disk hard drive, so disk space. So you've probably heard things like SSDs or HDDs or your hard drive. So whenever you're worried about how many files you can save, how much stuff you can save to your computer, this is the permanent storage. This is what we're talking about when we talk about hard drives and disk space. So that's something that you'll have to worry about, and you have a limited amount of that. That's what I said: CPU, memory, hard drive space, and I guess that's all of the. Another one is with both your network and your hard drives, you have another kind of resources you have to manage called I/O. That's input output, and that's a little bit different of a concept from what we've been talking about here, but we will learn about that in here. It's not quite the same as, I guess, worrying about your memory and your hard drive space, but just these are the kind of things you'll need to manage. These are all the resources that you have that are limited, that you kind of have to make sure are good and can affect the performance of your system or computer. So process management, how do we see what's running? And we have a few commands here. We have the PS command, which is, I think, just this process or process list. I think it's process. We can look at the man pages for that, but a PS command, we're about to run all these. PS tree, I don't really use PS tree, but PS tree is another, it's the same thing, but it makes a tree of related processes. It kind of shows you which processes are branched off of others and things like that. Top, which is a great command that you'll probably use pretty often to give you a bigger overview. This will show you a lot more than just the processes that are running. It'll show you their how much memory is left and how much memory they're using, CPU usage, things like that. H-top, which is a cooler version of top. It's got some visual elements to it as well, but it won't be available on all your systems by default. Usually something you have to install. And then we'll talk about the kill command. This is just how you kill a command from the command line. So if you've ever used H-top is great, but GoTop, I will check out GoTop for sure. Maybe we'll install it in a little bit. I never heard of that. I'm gonna definitely check that out. But yeah, so let's hop into so on a Windows computer, I think you have, what is it called on a Windows computer? Actually, let's check here. You have your task manager. So task manager on Windows, this is kind of the command line equivalent to task manager on what is it on Linux? Is it activity monitor? Okay, system monitor on at least a Debian-based version of Linux, and I think inside of Macs, I think it's called activity monitor. But this is how you get all the information in your computer. So on here, with activity monitor or systems monitor, I can look at some cool graphs and I can see, hey, CPU is getting used 10% and things like that, and memory, I'm only using 3.4, and all that's important. I can see all the processes here that are running. Even though I'm not running many programs, these are all the background processes that are running. And I can also check things like disk space. I can see that, I have 80 gigs available, and I'm using 16 gigs, and the total drive space is 101. How do you get this information from the command line? So first, let's figure out how to get this process list. So a command we have is, let's actually man PS real quick. And yeah, report a snapshot of a current process. So you almost will never use PS by itself. So if I type in PS, you can see here, it shows you two things. And so let's just look at the breakdown of what it shows here. PID stands for process ID. This is one of the most important things you're going to be getting out of the process list is the PID. And you'll see it shortly why the PID is important. Again, PID just means process ID. It's not something special. These numbers don't really mean anything. It's just kind of the ID that it gives it. TTY, this is, I think it stands for teletype, but this is just where, this is like, if you don't have a TTY, you won't be able to type. And this just tells you, I think, where it's mounted, and where it's on the computer, where that device is. Time is the time that it's been running. It should, I wonder why that's 0. I wonder when we go a little farther, if that'll be more than 0. And then the command that was run is just right here. So this shell is bash, so that's why you see bash here, but you're almost never going to be running this by itself. So I commonly use this one. So this gives me all the information, like way too much information. If I think -a is all, and you can check here, but I think -a will show me all the processes. And cool, it actually it shows you see every process. You can use AX or AXU. So it's a lot of stuff here. I usually use -AUWX, and this shows me everything that I would ever need to know. Overwhelming. I know it's overwhelming, but what we do have here, again, over on the left, maybe I can scroll faster, maybe it can go to the top. See if we can make it cool. What we do have over here on the left is the user that's running. The user that's running the process is over on the left, and that's really important. You want to be able to find out what user launched a certain process. So you can see on the left what user launched it. You can see next the PID, or the process ID. We just talked about process ID. You can see what the number is for that process ID. You can see that there. Then you can see how much CPU it's using up currently. So this is a quick snapshot, and it tells you how much CPU something's using. So this is in order by PID ID. So you can see, let me go to something that's using a little more. Well, I'll show you an easier way later, but yeah, you can see how much CPU is using. You can see how much memory is being used up. And you can see some uptime on this. And then at the very end, you can see what the command is that launched the process. These are all important things. You'll see why they're important. Right now, just kind of know, I just want you to know what we're looking at here. It's not important that it makes sense to you. It's important that you understand what this process list is that we're looking at. PS3, you can use on your own. This is a more confusing view if you don't know what you're doing, but it's just showing what processes kind of branch off of other processes, and that is something you can use as well. It comes in handy, but I don't use it very often. Next is top. So actually, before we get to top, we'll see, were there any questions so far about this? Melagarda, I appreciate your love for the stream. But a design for my stream, that would be great. That would be great. I'm not a designer, and I try to design. Not very good, but I get it done for sure. Cool. Do you use Perl for text processing? I do not use Perl. I do not at all. Cool. So let's see here. What did we just do? We did PS and PS3, and let's do top now. So top is a great command. So one of my first big boy jobs, I guess, was I was doing Linux server administration for a hosting company. And so all we did was log into Linux servers all day. We would watch a board, and we would get alerts, and we would go in and address problems all day. And top was essential for me to do my job. Took a little bit of time for me to understand all the things that are in top, but it's a great tool. So let's start from the very top. No pun intended, I guess. But first thing we have here is the uptime. So if you want to see how long a system has been running, you can, run top. You can also just run uptime. If you need to know that, you can run uptime. It'll let you know how long something's been up, and you can actually see uptime just grabs the first line of top, actually. But cool, we'll just go to top. Top is kind of a gathering of a bunch of information. It's a consolidation of a bunch of information. But uptime's been up for 20 hours, 58 minutes, 18 seconds. Not sure what this is, to be honest. One user is logged in. So if you have a system that many people log into, this line will show you how many users are inside of it. Load average. Load is some kind of calculation between the amount of cores you have and the amount of utilization there is. So it was very interesting. While I was at this company, I guess because of the systems that they were running, we learned that the load average of 1 was like when a server was overloaded and when it was bad. And so because of that, mentally I used to always think like, once it gets to 1, like computer struggling. That's not necessarily the case. That's not the case depending on how powerful your computer is. If someone knows a little bit more about what the load average or how it's actually calculated. Definitely shoot that out there. But the load average does give you some indications of how overloaded a CPU is. One is 1 core's worth of load. Okay, got it. So yeah, so one is 1 core's worth of load. So my computer actually has 16. No, my computer has 8 cores, 16 threads. I think my virtual machine has 4 cores. I think I gave it four of my cores, 2 of my cores actually. I gave it 2 or 4 cores. So I guess a load of 4 would mean I'm at 100% utilization. So thank you for that. Because I never really knew. I thought it went a little deeper than that. I thought there was some other kind of calculation that went to it, but that makes sense. A number of 1 is equivalent to basically 1 core. So cool. So you can watch that load average, especially if you know how many cores you have on your computer. But this lets you know kind of the load that you have on your computer. You will notice, as your computers are being overloaded, you will be able to watch this number shoot up, which is pretty interesting. And you'll kill a process or something, and you'll watch it drop, and you're like, all right, cool. I think I got it. I think I figured out what was going on. But there's a lot of other stuff here. Your number of tasks that are running, the status of them, some information about each of your cores here, your CPUs. Your memory, so this is how you find out a little more information about how much memory you're using, and it's in megabytes, megabits. Something for swap, all that stuff is up top. But down here is what we care about, the process list. So you can see here, we've got the PID here, process ID, remember that. The user that's running it, so you can see a lot of these are being run by the Ep6 user, but then there are a lot being run by the root user. So the PR, I think, is the priority. Can't remember for sure. And the nice is the nice level. The nice level will actually help determine priority for sure. So those are 2 things that kind of let you know if you want to give an application kind of more priority to your cores and memory, etc. You can adjust these values, and that will make a certain process more important. Vert, I think this has to do with the file system, the virtual FS, I believe. Not 100% sure for that, but what you care about is these 2 things over here, and then you care about these 2 things. You care about your CPU and your memory, so you want to know what's using up most of my memory. So by default, I think top will display everything CPU first, or maybe I passed it. Yeah, I think so. Top displays the thing that's using the CPU the most first. So that's how it orders it. So you'll see these switch up a lot, so it's a little confusing right now. And then the next thing is memory. I think you can hit like Shift M and it'll switch to memory utilization. So it'll order these things by memory utilization first. And then the uptime, the amount of time this thing has been running, and then what the actual thing is. So again, top's pretty cool for that. And then we can do HTOP. So HTOP is kind of top on steroids. It shows you, a graphical representation of your CPU cores. So it looks like I gave this virtual machine 4 cores. And it lets you know a visual representation of the memory and the swap space. Still a lot of the same information. You still have your uptime, your load averages, and your tasks, things like that. So, and then it's got the same information here, but you can obviously see it's a little bit easier to read. It does add some nice features to be able to easily make changes to a lot of these processes. But this is how you can kind of get a high level overview about what's going on. So again, a use case for something like this is, again, you can see maybe you got an alert. The alert came out and said, hey, this machine here has been running over 80% CPU utilization for 5 minutes. And you say, okay, cool, let me log in and see what's going on. The first thing you're going to do is you're going to go in, and because you know the CPU is being used up, you can go ahead and run top. And again, because it sets in this way by default, you'll be able to look at probably the first process or the first few processes and figure out exactly what it is that is kind of killing the things that you're doing. So that's pretty cool. Now, what can you do? What can you do to manage these processes? So there's a lot of different things you can do. Again, like changing that nice level to change priority. There's a lot of different things you can do with that. But one of the big things you're going to be doing is killing processes. So how do you force kill an application? So Windows, this is like when you hit Control Alt Delete and you force quit an application. You right click it and you kill it off because it's causing problems. Let's see if we can. I'm going to open something up. Oh, actually, GIMP's running. Let's do this. I'm gonna show you something cool. open GIMP back up. We're gonna string a couple commands together to show you how you would do something like this. So maybe GIMP right now, maybe GIMP isn't running, maybe GIMP isn't taking up all of my CPU. Maybe it's just stuck open and I want to kill it. We can string some commands together really quick to find out what our process ID of it is. So maybe I'll go here and maybe I don't see it in this list here, which I don't currently, and I'm like, oh man, what's the process list? What's the process ID of GIMP? Because I want to kill it. There's some ways in top to find it, but I like to do it outside of top. You can do, so we talked about that PS command, and I'm going to pass in my same stuff because I just want all the info. And then we're going to run a pipe. We never talked about pipes. This is the key over the /, probably right under your enter button on your keyboard. You have the shift and the slash button, and this is what a pipe is. And so what pipe will do is take the output of the left command, it'll run everything on the left of the pipe, and it'll pipe it into that data into whatever comes on the right. So we talked before about the grep command last time. This is string search. So grep is like the if you hit Control F in a browser and you want to find something on the page, you type that into your browser and it finds every instance of that on a page. Grep is just like that. Strings we learned in programming. Again, that's just a list of characters. Think words, think sentences, and so we can search for a string here. And I'm going to search for GIMP. I know the process is probably called GIMP or has GIMP somewhere in it, so I can grep for GIMP. And when I hit enter, I get the information. So basically, it ran this ps AUWX command, and that gave me a lot of output. And it basically took all that output, and it pushed it through the pipe, and it pushed that into the grep command. And grep said, hey, let me find all the lines that have GIMP on it, or GIMP available to it. And it spit those out for me. So it's a good way to filter lists and things like this as well. And again, GIMP showed up in red because that is the term that I searched for. If I typed in just GI, I probably would get tons of other things. And you can see here I got tons of others because GI exists in all of these things. But let's go back and get the stuff called GIMP. Now, remember we talked about the process ID being important, so that's what I care about the most. I care about this process ID, and I'm going to grab that process ID. So I'm going to save it, and I can kill GIMP actually. So GIMP is running right now, and that kill command. If I just type in kill and this process ID and I hit enter, this you can see here it's no longer running. It killed that process. And when I run the ps AUWX and grep GIMP, you can see how those options didn't come up. Now this right here, this one will always show up when you run this because this is the actual grep command that I run. So when I run this gets put into the process list. This is a process that actually gets run, and this grep is it finding that same process. So if I don't want to find it, I think I can do a -I maybe, or maybe I don't know. There's a way to ignore. I don't know. Maybe somebody knows. There's a way to ignore what comes out of that. But you can do, someone asking you to do 2 pipes. Yes, you can do multiple pipes. So I could grep -v. Yep. Thank you. And I don't actually need any quotes. I put those in there. But maybe do I need to still, shouldn't even do that. It's weird. All right, cool. Well, ignore that for now. But there's a way to ignore the command that you're actually running, so you don't get any info back. V is the opposite of, okay, yeah, so V is everything else. But let's open GIMP back up, and let's run it. So we still have this again, and maybe I want to find this other process that's not the GIMP process. I could pipe it to another grep if I wanted to, and I could say also find, say /user/lib, because I know that's a file path. And it didn't find that for a very good reason. I'm searching for a string. You can see the mistake that I made here. I was looking for this, but I typed it in with an E right here. And so you can see it's not a fuzzy search, it's an exact match. And this only gives you back one option. So it basically piped them through, and you're gonna have unlimited pipes. So it took the data from this, sent it over to this command processed that data, and then it took that data, the output, and it piped it over to this command, and now we've filtered down to this. So yes, you can use unlimited pipes to be able to do different things. And now it doesn't have to be used just with grep. There are a lot of things that it could be used for. Cool. Let's clear that. So that's process management. That's basic process management. And that's how you can kind of easily see what's running on the computer and how you can kill things. And that's kind of the basics of it. That's the things you're probably doing a lot in the beginning. Cool. So now we talked about those resources. Let's talk about memory and storage. How do we check memory? How do we check storage? So memory has a few options. We already saw that you can do it in top. We can see here that we have our memory here, our lines here. This is a little confusing to look at. I don't usually check memory here. We saw that same output is available in htop, but the common one you're going to use, or the one that I would recommend, is free. Is the free command. So you'll get, just a little bit of output. This is very confusing because this is in bytes. But you can see here, take a look at the columns that we have. We have the total amount of memory. We have the total amount of used memory, total amount of free memory, shared, the total amount of buffer or cache, and the total amount of available memory. And the second line we have down is swap. So if you're not familiar with swap, swap is actually it's a set aside piece of disk space, so actual hard drive space. So we talked about memory, and then we talked about hard drives and disk space. This is a set aside piece of disk space to take some things that are in memory that have aren't frequently accessed or haven't been accessed recently, and move them over to disk to increase performance of your RAM, as well as be able to give you a little more overflow there. So swap's pretty cool. Swap's a really good thing. I don't find it as important now because computers run with so much memory. My desktop has 32 gigs of memory. I'd never hit that. Something I never hit. But you will see this swap thing down here. Cool. So the reason it's so confusing is that it's in bytes, and we don't want to see it in bytes. So let's look at man really quick. And man just lets us know it displays the amount of free and used memory in the system. And maybe we want to scroll down and see how to see it differently. So it says B displays the amount of memory in bytes, and then we can see it in kilobytes here. Then we can see it in megabytes. On gigabytes. Yeah, cool. So we will do this. We can take that. We can also see this -H, which is pretty cool. Show all output feels automatically scaled, and we can pass it in one of these to give it to us a little bit better. But -H makes it human readable, which is an interesting option to throw into this. So if we do free -H, it makes it human readable. So it throws it to us in gigabytes now. So it says I only have 7.8. A little bit of memory and disk space is always used up by formatting. By formatting. So it'll always display a little bit less than what you actually have. This has 8 gigabytes of RAM. And so I've used 2.9. I have 1.3 gigs free. And you can see how these two things don't add up. 2.9 plus 1.3 does not equal 8. But it shows how much shared memory I have. And it has this buffer cache. And then it lets me know what my available memory is. And this was really confusing to me when I first started learning about how to determine how much free memory I had, because I would always look at this and be like, hey, you only got 1.3 gigs free of memory. Maybe you should upgrade your server. And people were like, what? Like, that's crazy. And but these things get put into cache. So this number is basically, it's almost this buffer cache plus the free memory. It's almost that. There's some things that get taken out of there with shared. There's some things that can affect this with swap. But the available one is what you care about, because this buffer, this cache memory is still, it really is still available to you. There's some times of high performance when that's not the case, but don't worry about that right now. For all intents and purposes right now, the available memory is the one that you care about the most. This will be the most accurate one for you trying to determine whether or not a computer has the headroom or the resources to do what you want it to do. Cool. So that's how you find out memory. So we covered that one, and again, you can find that with top and htop as well. But let's move into disk space. So hard drive space. How do we find out how much hard drive space we have? There are two commands we can use to kind of figure out disk storage and file system storage. So df is the first one. This checks the file system. Whoops. And so I'm going to add a -h here because -h makes things human readable. You can see the difference between the first one and the second one. We'll clear that and we'll add in the h again. And so this may be a little confusing too, but all this is on the left column is the file system. So if you have multiple hard disks, they'll all be listed here. If you have multiple, temp file systems, they'll be listed here. For if I had any snap packages installed here, the way that gets set up, they will be installed here. I think Docker does some weird stuff in here as well. But however your hard disk is partitioned, whatever's on there, however things are mounted, it'll show them all here. It's pretty easy to find the one that you care about the most. Your root file system, again, always look for the slash here. You can probably find it. It'll probably be the largest one. But this is our main file system, /dev/sda1. Unless you change it, it'll very likely be a /dev/something. And so we can see that my total hard disk size for this file system is 95 gigabytes. I'm using 16 gigs. I have 75 available to you, and this use percentage just says I'm using 17% of it, and it lets me know where this file system or this disk is mounted at. So again, I told you the root of the file system, you should be thinking about /, so this is mounted here. We'll talk about mounting to things later and like where you can mount things to, but that's essentially what this is. There's a lot of other stuff here that you don't need to worry about right now. Just know that breakdown. Know on the left, you'll see your disk. It'll tell you the total size in the next column. It'll tell you how much of it is being used in the next column, how much is available, the percent used. This one's important. So if you ever have any systems issues, and you're like the system's really being bothered and you log into it and it's going real slow and your commands are taking a while to get inputted, and you're looking at the disk, you look at the CPU usage and memory usage and you're like, man, like this is fine. I don't know what's going on. When a computer gets to 100% disk utilization, it can cause all types of issues. Sometimes it can be completely inaccessible, but watching your disk space is pretty important. Like, you should never let your system get to 100% usage, so make sure you're looking out for high numbers here. Cool, and that's how you find out about your disk space. And again, this is specifically file systems, so those hard drives, those actual file systems that you have set up, as opposed to the du command, which gives you information about specific files and directories rather than a file system. And I'll show you the difference here. Clear that, and if I type in du, I'm gonna get a lot of stuff. This just went through and told me, like, this list is very long, and it's telling me the size of every directory and folder starting at my root file system, because I didn't specify. But what you can do is I can go back, and maybe I want to find out how big this Cerebro master zip is, even though it tells me right there. It'll tell me over here on the left. You can pass in some of the same flags. So it lets me know this is 14 megabytes. And you can do the same thing with directories, and it'll tell me how big each of the files inside of it are. So you can get some pretty good information about, the disk space that's being used up, and you can run some cool commands to kind of aggregate a lot of this stuff and to get a good information about the size of certain files. So, if you're worried about there's a way you can put together a command to find all of the files on your computer that are bigger than 1 gig. Setting max depth will tell it how far down recursively to go. Equals 1. And so it only went down a single thing. So it went into Cerebro Master and down 1 more. And it only shows those things. If I add in 2, it'll go down one additional directory, so you can use that max depth to be able to select what you want. But you can quickly see here how all the commands that we've run, how we've been able to pass in these extra little tweaks, these extra little tools to make it do something very specific. And that's half the battle of getting. That's the difference between knowing Linux and like understanding how to get around and use Linux and being great at it. It's once you pick up enough of these understanding of these tools and what their full capabilities are, you can really do some really cool things to make your life easier, to make systems run better. But yeah, it takes time to learn these things. It takes a lot of Googling, it takes a lot of playing around. There's no way to really find out stuff like this unless you either go through the man pages, which is boring, or you're Googling around and you're trying things and you're looking for answers. You'll come across a lot of stuff like that for sure. And maybe you were running just DU and you were getting all this stuff, and maybe you Google, say, hey, how do I limit my search results with DU or something like that. So that's how you kind of find out more information about something. Or you can, I could pipe all that information to grep, or I could pipe it to awk or some other tool to kind of string together commands to do some pretty cool things. Take some RMRV. So no one should actually, I think Linux is smart enough now to not let you remove. So rm-rf is a way to remove things from your system. I think Linux is smart enough not to let you do that now. But what are my thoughts on Linux Plus? I think studying for the Linux Plus is great if your goal is to learn Linux. Like if you're a hands-on administrator, if you're doing a lot of Linux stuff day to day, I think Linux Plus is great. In DevOps, or at least in a lot of places I've been so far, the amount of Linux you need to know is, you need to definitely understand Linux systems, and again, I have a background in Linux, but you're not diving crazy deep anymore. A lot of that has kind of been abstracted away from you. So I don't know. It just depends. If you really want to be great at Linux, I think Linux Plus is great. I think it's a certification that's really good. But I'm not sure if your goal is to get a job in DevOps. I'm not sure how valuable employers see it, but I do think it'll help you truly understand Linux for sure. I think I thought I knew a lot about Linux, and I've talked to some people who have some Linux certs and they know way, way, way more about me, but I've never really needed quite that much Linux knowledge. So I don't know. Cool. So that is the disk usage command. So again, we've got df that checks the file systems, and we've got du, which checks the actual files and the folders and gives you information specifically about those things. So we've learned about how to check processes. We've learned about how to check what was before this. Processes, how to see what's running, how to filter that stuff out, how to kill those things. We learned about memory and storage as well, and how to see how much memory is being used, how much disk space is being used. And now let's get into some networking. So we are actually the class, next Wednesday's class, a class a week from now, is actually specifically about networking. And again, most of that will be inside of Linux. So this is going to be a very high level overview of networking tools in Linux and kind of how you interact with some of those things, and the options that you have available to you. So if you don't understand a lot of this stuff, don't sweat that either. We will be learning a lot more about networking next in 1 week from now. But right now we're going to talk a little bit about the loopback address. Really important. If anyone of you ever seen a shirt that says "There's no place like home," or if you've ever seen the IP address 127.0.0.1, that is the loopback address. That is your local host address. We'll talk about what that means and what that is. Talk about ping. I'll show you what ping is. Show you netstat. We'll show you ARP. I'll talk a little bit about Etsy host. This is just kind of me picking out some networking things just to kind of be able to get hands-on and kind of show you how networking starts to work in Linux and the different options you have available to you. Cool. So let's hop in. Here, what's happening? Oh, this is the last slide, that's why. Cool. So what we'll do here is the first thing I want to show you. let's go with first command we're going to run actually is most of the time you're going to be on a system. You really need to know you're going to need to know some information about what IP addresses and things are that have been assigned to the system. You're going to want to know what IP addresses assigned to your system, what network cards and what network things you have available to you. And the way you can do that is with the ifconfig command. So run ifconfig, and it gives you a bunch of output that's very confusing, especially the first time you see it. What this is a list of all of the network options you have available, so network cards, network attachments basically that you have to your system. So the first one here, I have, they'll all be named differently usually. This one is, I'll tell you right now that I know that this one right here is my actual network card. This is my main network card. This is the thing that basically has an Ethernet adapter plugged into it or is attached wirelessly. So this might be my wireless card. And one of the most important things you're going to get out of this is, right now I want you to ignore the rest of everything. I want you to look on the second line and see iNet right here and an IP address. This is the most, in the beginning especially, this is the most important piece of the ifconfig command. This tells you the IP address that is assigned to your network card. And so this is an internal IP address, but this is the IP address that my computer has. This is important for a lot of reasons. But you can see here, I have a whole separate networking thing here, and it has an LO tag. You'll always have, at the very least, you'll always have this network piece right here. This stands for your loopback address. So this is exactly what I was talking about up top. This is your loopback address. This is your home address. And remember I said it'll always be on every single computer you're on. It'll always be 127.0.0.1. Try to remember that. An alias for this is localhost. So it'll that address is alias to localhost. These are the same thing. Whenever you see localhost or 127.0.0.1, think the exact same thing. That is home. That is the computer that I am on now. That's always your local IP address. That's always how you can reference your own computer. Very important, like this, super duper important to know. Localhost 127.0.0.1. If I was, actually, let's see what happens. I want to see what I'm just checking what my Windows subsystem for Linux shows for my IP address. Okay. Ooh, there are way more here, which is good. Let me show you, let's see if I can show you this. Top view. All right, so this is my Windows machine. I know it's a little bit small, but when I run ifconfig inside of Windows Subsystem for Linux, I have way more here. So you can see here I have different IP addresses in all of them. And I have way more connections or internet connections basically. But again, I have all these things, but I still have this loopback address, which is still 127.0.0.1, which will always be your loopback address. So cool. Main. Let's go back to main. And cool. So IP addresses are maybe you don't know what an IP address is. That's something we'll learn next time. But an IP address basically is it's just like your house address. It's the number address to get to your computer via network. So networks aren't anything special. Networks are just protocols and lanes available for information to be able to transmit between computers. So that's all a network is. It's a whole group of interconnected computers. Each of these things gets assigned these IP addresses. It's just like your house address. It lets you know how to identify a computer or get to a computer. And that's kind of how the IP addresses are kind of how the internet works, really. We'll talk a lot about DNS next time, but I can use that address. That loopback address is important because I can always use that loopback address to talk about the network address of my computer. Like if I need to run something and I want to connect to my computer, localhost or 127.0.0.1 is how I can reference my home address. Like on a map, that's my home address. So cool. what else do we have on here? Ping. Let's go over ping really quick. So ping is a great way, and maybe it's best to talk about how to use this in practice. But if you ever want to check really quickly, you're on your job, someone calls and says, say you work for Google, says, hey, Google's down, the whole site's down, it's just down. The very first thing you might want to do is, before, maybe you want to try to hit it from a browser first. If you're already inside of a terminal, maybe you want to do this first. But you can type in ping, and you can type in the name of the address that you want, or you can do an IP address, and you can type enter. And what that's going to do is there's a protocol called ICMP, and it's just going to kick out a message to this address, and it's going to wait for a response. And what it does here is it just lets me know, it kicks out that message over and over again, and lets me know if I get a response back. It lets me know how long it took. It lets me know what number in the sequence it is. But why that's important is it's a very quick way to determine if an address or an endpoint is responsive at all. This isn't always the most reliable thing to do, but it's a common thing to do for most popular websites. A lot of things running in AWS. AWS does not allow ICMP by default, I believe. So you might not get requests back from stuff that's running straight out of AWS. People kind of have to put in some extra measures to be able to deliver this back to you. But at the very end, whenever you stop it, it'll run indefinitely until I stop the command. Control C is how you stop any command that's running via the prompt. You hit Control C and that'll stop it, and then it'll give me kind of a summary of what happened. It says 10 packets were transmitted, 10 received back, 0% packet loss. That means that Google was able to accept all of those packets, and it likely means the person reporting that Google is down has a different problem. Maybe their own personal internet connection is down. You'd be surprised at how many people will call you and tell you a site is down, and it's actually their own internet that's down. I've run into that plenty of times, but it'll give you kind of that aggregate here of what happened. So ping is pretty cool. Like we can ping like our site, and it'll give you the same stuff. It'll also give you it might also give you the IP address or some of the names, canonical names that you might be hitting here as well. But yeah, that's a pretty quick way to check if an endpoint or a site is responsive and accepting connections. Let's go to the next one. So NetStat. NetStat's a great one. NetStat is one that took me a while to learn how to use well. There's a lot of use cases for it, but what I use it most for is, let's say my company is running a Node.js application, or anything over the web. We'll say, hey, it looks like one of our web servers may not be responding properly. Can you check what's going on? Maybe I'll go and check. Maybe I'll first run a ping command. Maybe I'll check the site and say, hey, like, it doesn't look like I'm getting anything back from ping. So if you actually ping something that's not available, let's say I pinged gaggle.com. Oh, it looks like somebody actually has something up at that. Let's just type in some random stuff. Okay, name or service unknown. I wish there was a site that was down that I knew of, but it will basically give me 100% packet loss or a certain percent package loss, which will let me know it's probably down. But maybe I ran that first, and it looks like our web server may be down. I'll check in the browser, and it looks like our site really is down. I know that maybe a web server is supposed to be running, so actually let's do something. Let's do apt-get install Nginx. Nginx is just a web server. Don't worry about that. I just want to install it really quick to show you something cool with NetStat. But NetStat will show me the things that are running, and I can also see what port they're running on and a little bit more information. Let's look at the man page for NetStat. Yeah, print network connections, routing tables, interface statistics. So I can also use NetStat to see like how many people are connected to a certain port. So if I'm like, things seem to be getting overloaded, and I want to see, I have different applications running on different ports, I can put together a cool NetStat command to see like how many people are connected to an individual port, things like that. So I can do NetStat, and maybe copy this down. I use this. People do put it in different order. Like the order of these flags doesn't really matter, but this gives me all the information that I need. I can show you the man pages what all those do, but I'll do netstat-tulipin, and I get all these things. So we'll talk about TCP and UDP next time. These are different protocols, but what matters here is this local address. So this is the port here on the end. So this is an IP address, and we see a colon after an IP address, and there's some numbers. That's the port. So it looks like there's something running on port 80 and 53 and all this stuff. So let's say maybe I want to check. I know that web servers run on port 80, and I want to see if something's running on port 80. I can do this, and I can see here that both on TCP and TCP6, TCP6 being it's IPv6, which, so real quick on TCP6 versus regular TCP, basically IP addresses, these addresses that we're talking about, that only have 4 octets basically, they're running out. There's so many systems and things out now that we're actually exhausting all of these things. So just like we did with phone numbers, when, a long time ago, maybe 15, 20 years ago, definitely 20 years ago, we had 7-digit phone numbers. So, my phone number used to be 555-6676. And then they exhausted those things. So many people got phones, we had cell phones and things. We had to expand that. We had to add area codes so that people could basically reuse those 7-digit numbers in different states and different regions, and still be able to get the calls that they needed to better facilitate, the amount of people who have phones. This is the same thing that's happening here. Currently, we're on IP version 4. We're moving to IP version 6, and basically now there are way more letters and numbers that they can use to identify your address, which means there'll be a lot more to go around. Because again, these are like addresses. These are like addresses in real life, like street addresses, so they have to be unique. And so that's the difference between TCP versus TCP6. A little bit of a tangent there, or IPv6. A little bit of a tangent there, but netstat lets you kind of see these things, and it lets you get a little more information on the connections that are kind of active on your machine. So that's what netstat does. It shows you active connections on your machine right now. What else we got? We've got ARP. So ARP, I haven't had to mess with the ARP table in a while. Now I'm going to show you this. Don't mess with ARP at all right now on your computer. You can type in, once. I forgot how to list them all. I probably shouldn't be just typing in ARP commands, but ARP tables are pretty important. ARP tables kind of translate IP addresses, I believe, into like Ethernet addresses. And this is just another tool that you have available to you. As you learn a little bit more about networking, you'll understand the need for that. You probably won't have to mess with ARP tables often. Thank you, ARP-A. I assume there'll be some more, but whatever. Cool. ARP, it's a tool. You can do a lot with it. Just wanted to shout it out since you're available with it, because I know in a lot of jobs, like I think only like the 3rd day of that first job that I had, like the 3rd day we're having some networking issues. They were like, did you check the ARP tables? I'm like, I don't know what you're talking about. And then someone had me rebuild the ARP tables, and everything was working, and I followed some guides. But ARP is, I believe it translates IP addresses into Ethernet addresses, and we can do man ARP just to make sure. That doesn't help us at all. Manipulate the system ARP cache. ARP manipulates the kernel's IPv4 network neighbor cache. Connect entries to the table. Address resolution protocol. Cool. Yeah, that's network jargon. Networking is probably my weakest point in all of Linux and technology. The great thing is that now we have software-defined networking with the cloud, so it's done a little bit differently, and I can do that very well without having to worry about this. A lot of this, again, has been abstracted away from me on a daily basis, so cool. So ARP tables, those are cool. Don't mess around with your ARP tables. And I want to show you something with like etc host. So let me show you something cool. So you can control pretty much every aspect of your local networking or your machine's networking. One of the cool files you have available, one of the cool things you have available to you is this Etsy host file. So people will talk about their host file. And what you can do here is you can use your host file. And again, we'll talk about DNS next time, but you can use it to assign, basically tell your computer that an IP address goes to a certain name. So this is how you can basically lie to your computer or tell it manually where the address of a certain domain name is. So I talked about that alias before. I talked about when you see localhost, you should think 127.0.0.1. Your computer knows that because of this line right here. It creates an alias here. It says, hey, whenever someone types in localhost, whenever we want to reference localhost, I want it to point to this address. Don't mess with any of this stuff, but you can put a new line in here. So maybe I want to say, first off, let's do this. Let's look up the IP address. I'm gonna dig google.com, and this may not work, but so this dig command that I ran is how you can grab an IP address. I'm gonna steal this. I'm gonna save this, and I'm gonna say every time we go to, let's say Aaron is the best.com, that it will go to that IP address. So theoretically, that should take us to Google, but it might not. It's read only. Let me copy this real quick. Actually, because this one is a read-only file, I have to sudo pimit, and let's paste that in. Oops. What did I say? I said paste. Aaron is the best.com. We'll save that, and hope now when I go into the browser, should be able to go to Aaron is the best.com, and theoretically it should take me to Google, and it does. So it gives me a 404. It gives you some errors because Google has some Google's done some things that allow you to not be able to do things like this, but this does take me to Google servers. It takes me to Google servers, which is nice. There are some ways around it, but yeah, so that's all. That's what the host file does. So some reasons you might want to use a host file might be for testing purposes. So maybe you're working on developing something locally and you want to be able to, you need to be able to enter in a domain and test it properly because your site takes in some type of checks for some domain parameter, etc. And you know, so you can locally, you can say, all right, whenever I go to this website, you know, point it to my local computer. So I can also make this an alias for, you know, that localhost address. I can make it for 127.0.0.1, and that will try to hit my local computer to be able to find something. Or I can send it somewhere else. So there's a lot of reasons why you might want to use a host file to kind of redirect your DNS to somewhere else. And let me remove that from here. But yeah, it's a cool way to kind of adjust how your computer is reaching out for information. Again, really just showing you all this stuff to show you that there are a lot of tools available to you, a lot of options available to you. Everything that you can do from the GUI, you can do here. You can actually do more from here than the GUI. And I think that's all. I think that's all we should get into for networking this time, because if we dive any deeper, you get real confused because there's a lot of layers that we need to build on for you to kind of understand some of this stuff. Again, things like DNS, things like protocols. Those are all things that we're going to learn next time. I've been ignoring the chat again. Let me see. Anyone have any questions? Talking about the IPv6 expansion. Cool. Yeah. That's it for tonight. Does anyone have anything we didn't go over? Was anyone confused about anything? I can give you guys a little bit of time left back into your night tonight. Too many people I've seen develop locally and don't test the site against DNS. Very true. DNS is very important, and DNS is actually pretty simple pretty simple at first, but it can get complicated. Like managing DNS and getting DNS right can get quite complicated actually. But the high level idea of DNS is basically DNS is how when you type in Google to your computer into your search bar, or you type in, you know, Mastermind Academy to your search bar, it is how, whoops, what did I just hit? It is how your computer knows where to go find that information. So I think DNS stands for domain name service, and basically when you type that into the browser, it basically sends a request out to something called an authoritative name server. It says, hey, I want to go to rubylang.org. I don't know where that is. Can you tell me where it is? And it will do its best to send you to either a series of DNS servers, or it may have the answer for you and say, hey, this is the IP address. This is the address in which ruby-lang.org is, and it sends that back to your computer. Your computer says, okay, now I know rubylang.org is at 928.135.440 or whatever, and then it goes back out and it finds that it follows the path. It basically puts it into Google Maps and figures out which server to go to, and that's all DNS is at a very high level. Managing DNS is it can be really cumbersome, to be honest. It could be pretty simple for if you just are kind of setting up a website. You basically buy a domain and you say, all right, you buy a domain, you buy a server, they'll give you the IP address for that server, and you go in and you say, all right, DNS, I want you to send, you know, all requests for this over to this IP address. And that's basically how it works. Again, very, very basic. We will dive a lot deeper into that next time. Yeah, DNS, exactly. It's super easy until it is not. Shig White, absolutely. Thanks for tuning in. I really appreciate, again, all the people helping me answer questions. Again, I'm not, I tried to express this in the very beginning. I know a lot. I don't know everything. So I like when people, you know, add in tidbits, things about the app update versus upgrade. I throw those out there. Don't feel scared to like, I don't want to like step on his toes. Absolutely. Throw those things out. If you have any feedback, if you have any things that you think will be beneficial to the channel, throw the things out there. Reach out to me in the Slack channel. A lot of people have been doing it already, and I really, really appreciate that. Again, we're here to learn as a community. Again, a lot of this stuff, honestly, as we start to go over it, I forgot about a lot of this stuff. I probably should have dove a little bit deeper before this one, but diving into this stuff, again, because I haven't had to do a lot of hands-on Linux administration in a long time, a lot of this is like, oh, cool, I remember this, but maybe I didn't know, you know, how this worked, you know, in its entirety or something like that. So it's pretty cool. This is a fun learning experience for me as well. Yeah, I like this collaborative nature. Thank you again for being so like helpful in the chat. It's really hard to try to get through this stuff in 2 hours, but also be as attentive as I kind of want to be to the chat. But yeah, but again, we're also going to be in the future, we're going to be doing more than just this DevOps Bootcamp. This DevOps Bootcamp is kind of a test bed, because there's so many different topics, to see what it's kind of like to go through each of these topics. I'm probably going to be doing a bootcamp for every major piece of this, like an individual one. Again, Linux one will be next. It'll probably only be a 6-week bootcamp though, but a very in-depth Linux bootcamp. Zero, like full-on zero to hero. I won't just be kind of throwing you to the wolves and giving you a high level of everything. But we'll be diving real deep. One for cloud computing, one for programming for sure. Those are the ones that are slated right now. Those are the ones I'm building out right now. So definitely keep an eye on those. Most of them will be, I think the Linux one I will do before the new year, but I think all the rest will be slated after the new year, and I'll probably be doing 2 at a time. Again, offset days, still twice a week, with a supplementary stream on Saturdays. I do plan on doing a supplementary stream this Saturday for any questions. It'll be real chill. I'll probably play some games just because I like to play games, and it'll be a good time for me to play some games. But if anyone has any questions that I haven't been able to answer, definitely hop on there. I'd love to have some conversations there as well. Yeah, I think that's it. Terry, if that's a question for me, I have a really powerful computer, so I lean more towards VirtualBox. Light still costs money, which is fine. It's cheap. It's easier to manage, but I typically use VirtualBox for a lot of the stuff that I'm doing, like for test bedding. If I'm not doing something AWS specific, even if I am doing something AWS specific, I don't really use their VPS service. I will probably use EC2 or some of their other options, but we'll learn about all that as well. But cool. Thank you again for tuning in. This was a good one. I hope that I have a whole list. I started the resources channel in the Slack. I have like 7 or 8 resources for you to dive deeper into Linux. There's a lot of information out there on Linux, so it takes time to get into Linux, pick up some of the basics, some of the essentials, learn, get comfortable navigating the command line, and then you can just build from there. Once you can navigate the command line comfortably and, move forward, move backwards, make a directory, delete a directory, create a user, things like that. Just keep building, learn a tool a day, learn a command a day or something like that. And, in 2 weeks, you got 14 new commands that you didn't know before. And it's very easy to pick up a single command every day. So in a week, you can know 14 commands really well if you want. Or in 2 weeks, I did that math way wrong. But yeah, so I'll post those links into the resources channel. So definitely join and check that resources channel out. Yeah, and that is it for the night. Again, thank you everyone for joining. Monday we're back. Monday's Labor Day, and again, if you can't make it on Labor Day, no big deal, but Monday we're putting all the Linux stuff together, and we're going to be doing some bash scripting. So I have a lab put together where we're going to be acting like we are starting a job, and not starting a job, we're on a job, and we've got to set up a system, and we kind of want to automate some of those processes, and we want to create users, create groups, set up files, install some packages, remove some packages, things like that. We are going to do that on Monday. So yeah, hopefully you'll be around. If not, go ahead and watch it afterwards. It will be recorded. But yeah, that's it. I will see you all next week. Happy Labor Day, everyone. Enjoy your weekend. Yeah, I'll see you next week. Have a good night.